This is the linear transformations review video. We have been working on transformations for a couple of days in class, and the first thing that we did, we actually started this on Thursday. You guys set up your foldable. So hopefully you have this foldable completed. If for some reason you don't have that, you now have access to the foldable here and you can recreate it. Or remember, I showed you how to access it on my iTunes U course. So you need to make sure that you do have your foldable, as I will be letting you use that on your quiz. And plus, this is going to help you memorize this notation and what the actual transformation is. So the first thing I'd like to do is just talk to you about the function notation, what the transformation looks like in words, and then what it looks like on a graph. So the first transformation that we talked about is when we have negative f of x. So remember, we graphed f of x as x plus 2, and that is the green line that we graphed on each of these coordinate planes. So notice that green line is the same on all 10 of these. If I'm going to be graphing negative f of x, what I'm actually doing is I'm multiplying x plus 2 times a negative. When you do that, it's going to create this new line, which we call g of x, and it is going to reflect that line across the x-axis. Notice f of x and g of x, they have the same slope, only one of them is positive and the other one is negative, and they share an x-intercept. That's how I know it's reflected across the x, because it flipped, but it maintained that x-intercept. Okay? Now on the other side here, we have f of negative x. Notice the negative is inside the parentheses here. What that does when you go to graph or create g of x is only the x gets multiplied by a negative, but the y-intercept remains 2. So notice my green line has a positive slope, while my pink line, which is g of x, has a negative slope. Therefore, it has been reflected across the y-axis because they share a y-intercept. Remember, reflect means to flip. So while this is positive, this is negative, they share a y. Okay? Now, the vertical translations seem to be a little bit easier for you guys. Notice we have f of x plus b and f of x minus b. We talked a little bit in class about this notation, and you guys pointed out that that plus b or minus b, you are used to seeing that with slope-intercept form. And remember, b in slope-intercept form represented your y-intercept. Therefore, it helps you remember that this is a vertical translation. If it's plus, then it translates up, and if it's minus, then it translates down. So when you see f of x plus a number or minus a number on the outside of the parentheses, just remember that that's like changing the y-intercept. So here, this one happened to shift up 1 because we did f of x plus 1, and here the y-intercept shifted down 1 because we used f of x minus 1. For the next set of transformations, we have f of, and then the quantity x plus h or x minus h. So when we did this, we talked about the fact that if there's a number inside the parentheses, that's actually going to translate our line left and right. So the way that I tried to show you guys and to help you remember is that when you're adding to x or subtracting to x, you want to look at the transformation of the x value. So on this green line, we have a point, and it is translated to the left 1 unit when we added 1 to x. So notice that's inside the parentheses. Over here, my green line is translated 1 unit to the right when we subtracted 1 from x. So those are horizontal translations. It goes left if it's positive, and it goes right if it's negative. From there, we worked up and down right here, so we had f of a of x, and so we talked about the fact that when you multiply a number by x, that if that number is bigger than 1, it's considered to be a vertical stretch. So what I tried to tell you guys is, if we took this green line and we stretched it, that means we pulled it up vertically, that's going to create a steeper slope. Okay? Here, if the number in front of x, so if a was a fraction, so a number between 0 and 1, it's going to cause a vertical compression, which is also known as a vertical shrink. So I told you guys, if we push that green line down, compressing is like pushing it together, it would create a line with a less steep slope. It's flatter, that pink line. Okay, so notice here A was 2, that's what made it steeper. Here A was a half, and that's what made it flatter. Over here, when you have a number on the outside of f of x, it is going to affect your line horizontally. So if A is greater than 1, it's going to be a horizontal compression, which actually changes the y-intercept and makes the line steeper. If A is a fraction, it's going to create a horizontal stretch, which once again changes the y-intercept, but it's going to make your line less steep. This is the assignment that we completed in class where I taught you how to utilize your foldable. So I'm going to go over these first two with you just to remind you the process of how to actually break down these transformations. So the first thing that you want to do is you want to look at the rule. So notice right here, first of all, the instructions say determine the effects of each graph for the transformation. So on number 1, they're asking you from f of x to g of x, what's happening? So notice they've given me two pieces of information. Here they gave me the rule for f of x. F of x is equal to 2x plus 3. Here they're giving me the rule of what happened to f of x to create g of x. Okay, so g of x equals f of x minus 2. I circled this one because I need to know g of x and f of x to get the actual rule. Okay, so when you look at this, you notice that f of x, we have minus 2 on the outside. So when you go to your foldable, you're looking for the transformation that has minus b, because remember that's on the outside. So whenever you subtract a number from f of x, that creates a vertical translation down, and then the number of units is 2. And you can visually see that because if you put your finger or your pencil on the y-intercept, it shifts down 2 units to get to the new line. Okay? All right, so let's look at number 2. Here, we're going from f of x to g of x again. So notice here, they've given me the rule for f of x, it's 3x. And here, they're telling me g of x is created by doing f of x plus 1. Okay, so we're doing x plus 1, that's inside parentheses. So I notice here that we have plus 1 inside the parentheses. That's going to create a horizontal translation. Remember, it does the opposite of what you think it's going to do. So if I'm on my original line, it shifts it 1 unit to the left. So that's a horizontal translation, left 1 unit. So then in class today, I had you guys finish up this assignment in partners, and then we went over it. So I want to go ahead and put the completed version on here, just in case you didn't understand something or you didn't quite get it written down. This is the completed version of the assignment that I was just talking about. This is also posted for you guys on iTunes U in case you need any help. If you have any questions or you're still not feeling confident with this, we are completing practice A tomorrow in class together. And then you guys are going to have a short review quiz over 3.6 and 3.7. Remember that 3.6 was direct variation, so that will be on your test, and then we'll be testing over this material as well. If you have any questions, don't hesitate to come by. I have tutorials every morning. I'll see you guys later. Have a great night.